This is Dean Phillips for the Destiny of Manufacturing podcast. I'm here to thank everybody for attending today. This is a great opportunity. Today we have Mr. Ryan Bruce, who is the Director of Business Development for the IC.IDO virtual reality for ESI. And I'd like to thank him for being here today, and of course thank our sponsors, the Precision Metal Forming Association and the PMA's Educational Foundation, for being able to support this program. Welcome, Ryan.
Thank you. Thank you very much for the opportunity.
It's great to have you here. Please take a second and just explain to us what is IC.IDO and the virtual reality aspects that you're involved with.
Yeah, sure. So virtual reality is a huge term, right? So everybody these days has heard something about virtual reality. Usually it's more gaming oriented nowadays, right? So you have these things we call head-mounted displays. They duct tape them to your head, right on your face there, and you can live in the virtual world, play games day and night. You know, we're sort of part of that larger ecosystem, right? But we're obviously not focused on gaming. We've been around since before this current VR trend.
Right.
We started with VR in the sense that it was projected, right? You'd walk into a large room and you'd have a VR projection display. But our customers like the Boeings, the Caterpillars, the Fiats, the Daimlers, those guys, they use this type of software to validate their products, their design in virtual reality, so that they know that they can actually build their products before they end up spending the money to implement a production line just to test out their initial design.
Right. Now, when you say validate, can you expand on that a little bit and explain how you go about doing that?
Yeah. So validation happens in a couple different areas, right? So we like to refer to our product as acting within the space between the three P's. The P's are the person, the product, and the process, right? So if you're thinking of building the Mercedes C-Class, right? So there's going to be a station on that line that a person is responsible for manning. And that person needs to maybe use some tools to take apart and make a subassembly. And then that subassembly has to be attached to, we'll say, the vehicle. And the process is the order in which they have to do those operations. And then the person has to physically be able to perform those processes. So what we allow them to do is to don one of these head-mounted displays, walk up to that station, reach out with their own hands, grab in the virtual world the tools that they need, grab the parts that they need, put them together with realistic physics so that they can tell whether those are fitting together well. And then they can take that assembly, that subassembly, and they can put it onto the larger component. And they can, each step of the way, check and make sure that that's behaving correctly. So we have those sort of built-in physics checks and ergonomic checks so that we can tell the operator whether there are issues that they might need to be concerned about.
Great. I think that's an interesting term, saying realistic physics, because I really think that applies to exactly the experience that you have. Is when you try this out, you actually get a true feel for the space that you're operating in, and you get a true idea of what the ergonomics aspects that you're going to be faced with and the challenges of somebody doing this job for 8 hours. You can get a better sense of how this operates and the realities of that go along with it. Can I physically move from this point to this point in the given amount of time that I believe it can be done. That's
Mm-hmm.
and I think that's a bigger challenge than most people ever acknowledge.
Yeah, absolutely. It definitely is. The one of the primary things that people maybe don't upfront understand about the difference between our sort of flavor of virtual reality and the gaming flavor is that reality component of it. Yes, it's all virtual, but we spend a lot of time making it much more real, basically. Telling the people that are using the software what they can't do in reality.
right.
So you're able to take a component, say you've got the square block trying to fit in the round hole. With some gaming type engine, it might act a little bit flaky. You're going to get really fast performance. It'll look really nice, but it's not so much about the precision of the physics actions that you're doing. And that's kind of where we have to focus, because our customers are really interested in very detailed analyses like that. They have to know, within a very fine margin, if things are going to fit together. And that's a make or break sort of question for them to answer.
Sure. And I think it's very interesting that you bring up the gaming aspect of it, and without question, in the gaming world, they're trying to create a fantasy world where you're kind of faced with things that are not true and not real, where what you're trying to do is create the most realistic experience for operators or for people doing the testing to confirm that this is possible in the real world.
Yeah, exactly. And I may have mentioned this already, but we spend probably a ton of time and effort. The most of our time and effort is invested into taking this fantastic virtual reality thing where anything is possible, and then constraining it down and telling people what they can't do in virtual reality. So yeah, I mean, anything in theory could be possible, but that has to be really harnessed for good, such that our customers can get plausible answers, real answers that they need to save money and hopefully do things faster.
Great. One of the things that we do here at our podcast is focus on the 5-year picture of what is going to change. How are things going to change? And we'd like to get our guests' perspective on this. What are some of the things that you see changing in virtual reality that you think are going to be impactful in the next 5 years?
Yeah, well, hardware is probably the primary shifter right now. It's changing. I mean, just what was it? A handful of years ago, we had the Kickstarter for the Oculus Rift, right? And
Right.
Everybody was like, "Whoa, this is completely different." I mean, in reality, HMDs, head-mounted displays, had existed for a while, but that really kicked off this current trend. I think we're going to see this last for quite a while. You already have, I think, Gartner saying that VR is off of the hype curve, the technology hype curve. It's definitely into the industrialized technology already.
Mm-hmm.
And we're just going to see that Moore's law of technology applying on the hardware side. Certainly, there's a lot of gaps, a lot of improvements that can be made there to make it more usable, to make it higher quality, to maybe address some of the comfort issues that some people have. But then on the software side, I think due to the interest, you're going to have a lot more players, and you're going to have a lot more innovation for all of the people that are able to persevere in this market. And that could be in terms of applications. I still feel like a lot of the solutions I see out there are sort of they're more interested in the technology. They're like, oh, we want to do something in VR, but they're still searching for their killer app.
Mm-hmm.
We kind of found the killer purpose for our existence, the killer app, so to speak, and then developed the technology to meet that. But I'd say you're probably going to get a lot of development in a very short period of time. Within those 5 years, I would see a lot of things that we're currently doing using traditional packages at least have a virtual component to them. For us, we're really focused on this manufacturability problem. So we're going to be able to pull in more and more things like cobotics, 0D, 1D simulations, these extra things that you can pull in to add additional value to the studies that you're already doing in the manufacturing space, making it more immersive for the person that's using it, getting full human analysis in real time, that sort of stuff.
Right. It's interesting you say that about using things like cobotics and being around that, because that's been a huge issue for developing safety. Has there been a lot more interest from the safety aspect of integrating people into the robotic space and vice versa? And how do you work around those challenges? Has that been an avenue that's really been expanded on?
Yeah, we do have people who are interested in pushing us farther towards robotics analysis. We can do currently in our software, system kinematics quite well. So we do like lift assist mechanisms, suspended loads. So if you're doing an engine install or a common robotic assisted operation is an IP and for a car, basically the full dash panel from driver side to passenger side. That's a huge component. There's actually a large structural rail back there, and a robotic arm usually fishes that in through one of the doors, the driver side or passenger side door, and then installs it into the front of the car. That's all obviously a very complex operation. That's a primary area of interest for a lot of people that are doing automotive work. There are so many different subsystems that are in there. And you have people working, near these operators, these robotic operators, and maybe doing work like putting fasteners in while the robot's holding it in place. Could be that the line is moving. It could be that the person is sitting on an assist mechanism of their own. So they could have a little chair that they're sitting on, and their chair is positioning them so they can ergonomically access these work areas alongside maybe another assist mechanism holding the work in place. And yeah, safety is the primary concern in those situations where you've got humans involved with difficult operations, maybe complex tools and robots or large sub-assemblies that, any one of those numerous things could hurt or injure the person involved.
Sure.
So we've seen a huge push towards human-centric analysis of operations. Can our people do this operation safely? Even just things as simple as scrape risks. If you have edges on a workpiece that aren't rolled or something, they're getting into very detailed analyses of like, okay, well, how likely is it that when this person reaches in with their tool into the assembly that we're building, are they going to scrape their arms on the sides of the equipment? Are they going to have enough space to fit their hands in there? That sort of stuff.
Right. I could see that being a great application for your system. Tell me a little bit about, walk me through the process when you're working with a company. how you go about developing what hardware they need, and more importantly, how you start to create the virtual space for them.
Yeah, those are good questions. So we usually start with just a conversation, actually, much similar to the conversation that we're having. We will talk about the types of problems that the customer typically faces, what's keeping them up at night, and then from there we can say, okay, well, you've got a lot of stuff that's keeping you up at night, or costing your company money. It looks like we can focus on these areas again between the three P's: the product, people, and process. Looks like we can focus on maybe a subset of those issues that you have, and we think we can provide some value in there. And the types of problems that they're facing might decide the types of hardware that they use. The head-mounted displays are right now they're actually kind of generically pretty good. They serve a lot of use cases pretty well. There are still use cases where they might benefit more from a power wall. A power wall is like I was describing before, a large surface, a large projection screen, which is usually rear projected with your 3D image. And that's really helpful in the cases where, like, for example, you have local collaboration happening, where you might have different interdisciplinary teams coming in and collaboratively working on designs or reviewing existing designs together. So then they can all stand, 10, 15 people in front of one of these systems, and they all get kind of a similar view. And that's in contrast to an HMD, where you've got one person who's wearing the HMD, and they're the ones really ingrained in the work. And there are even larger systems too that might be relevant if they're doing cabin studies, occupant packaging, full work cell analysis, where they want people to be untethered. Those things might lend themselves towards CAVE. CAVE. I think it's probably a trademark term, but it's a multi-sided system. So you have, like, that power wall projection system. You have that basically in the shape of a cube, and you can walk inside of it, and no matter which side you look, everything feels like the virtual world.
Yeah.
And so those use cases kind of determine, along with their budget and their space requirements and that sort of stuff, kind of determine the type of system that they need. And then on the second point, how we start to create their virtual worlds. Honestly, most companies are doing this work required up front every day, right? Every one of the companies that we work with, they come in the morning, they sit down at their screens, and they spend all day designing 3D parts, right? And
Right.
for us, that's really all that's required for us to pull those in and start giving them useful decision-making tools as an output. So we pull in their CAD files directly, whatever their product is. We can pull those CAD files in. And in some cases, the CAD files are really quite large. Think of a 787, for example. You're talking billion plus polygons.
Yeah.
Just some statistic that we're familiar with, but that's millions of parts, or at very least hundreds of thousands of parts. And we can pull that into our virtual reality software, IC.IDO, and they can start to manipulate it. So there's very little upfront work that they have to do to at least visualize what their product is. And then from there, it depends on what they want to do, right? So if they want to do a human analysis, maybe 5 clicks, and you've got a virtual human in the scene. If they want to do an assembly analysis, if it's changing a tire, for example, you can select the products from your CAD model that you want to start working with, set some properties, and I'd say within 10 minutes, maybe 20 minutes, you can virtually do a service study without actually having any of the physical components in place.
Hmm. That's really interesting how to be able to do it that quickly. I never thought that you'd be able to work on it that fast.
Yeah, it's one of the most surprising things, or most commonly surprising things for the new customers that we work with is, we tell them, well, it's pretty easy, and they're like, yeah. Everybody says it's pretty easy. So, right, and we're like, okay, well, can you give us some CAD files? And they're like, what, like our CAD files? Well, yeah, sure, okay. So somebody runs off, they bring back a USB drive, right? And 20 minutes later, they're arms deep in whatever problem they've been trying to solve for the last month, and they're like, "Oh, if only I thought of it this way, we could have solved this and spent X amount less." And I've had literally that situation happen to me. I can't even count the number of times.
Right.
But it's quick and powerful to experience in a virtual world the problems that you typically wrangle with.
Yeah.
As a manufacturing engineer, for example, those guys, they're kind of tethered to the real world, right? They don't get to really experience their problems until they're literally problems sitting in their lap on the manufacturing floor. And giving those guys the power to try and get ahead of some of those issues, that's really, for me, I enjoy that, right? It gives me a great feeling to like give somebody a tool to do their job better.
Sure. Speaking of jobs, obviously one of the biggest areas that of concern, I probably don't talk to a single company during the day that does not have some pain associated with workforce development, whether it's finding people, whether it's how to use technology to try and reduce the amount of labor that you have to have because they just can't find people. What do you see, over the next 5 years of either directly associated to ESI and to your products, or in general to training, changing over this time?
That's a good question. So we've looked at the training industry a lot, and we keep a really close, like a finger on the pulse, I guess is a good idiom there.
Right.
It's not something we've fully dived into, but we do get used for training, kind of related to these manufacturability validation type studies, right? If you go one step further with that, all right, we've validated in IC.IDO that this process can be done, right? And now, it turns out we have a really high turnover rate for these stations. We've already validated it. We've done the work in IC.IDO, but now we have a familiarization problem. Now I have 30% turnover, right? So I have to make sure that I can pull somebody into that spot. They may have never experienced how to do that operation before. Well, in those situations, we can give them some platform to familiarize themselves, right? Now, it's not a fully fledged training package or anything, but I think that's a really helpful kind of pressure release valve for these companies that are under really stringent requirements on the workforce side. It's hard to get people, hard to make sure that people are there. Everybody calls in sick. You've got various issues that come up. And you have to be able to rotate people in. I see training as being a pretty big market going forward. And I think virtual reality, augmented reality are in particular really well positioned to help in that market. And I expect from us, we will keep dipping our toe in the water there, and maybe in the next couple of years we'll jump, or maybe partner or something like that. But it's definitely interesting.
Yeah.
And in terms of finding people, just maybe the general problem related to virtual reality. So So we have challenges finding people too sometimes, as do our customers, who are skilled up the right way. But I expect the demand for this type of virtual worker. I expect that to grow. We certainly have a need on our side. Obviously, we have to have people that can operate our software to show our customers how to do so, and then the customers themselves. I mean, the technology usage is only growing, right? So it's going to be more and more that, okay, instead of taking your CAD and throwing it out to the workshop guys immediately, right, with a 3D print or a physical prototype, doing the traditional method, you're going to have teams of people. I'm envisioning this. You're going to have teams of people who are basically virtual builders, who are virtually building up your car and checking for those issues before you go to physical. And then the flip to physical, in theory, of course, is going to be more seamless and much more distinct.
Right. Well, I'll tell you what, I certainly look forward to that, because all I hear from everybody is, boy, we can't find good people. And I think that the more we can do to help fill that gap, whether it's through technology, training, whether it's getting people interested.
Yeah, I think university can help as well, too, by making sure that they've also been paying attention to industry and where industry is really pushing the boundaries, because that's gonna directly correlate to the requests for people. We will need people with a good physical sense of or mechanical sense, right? But able to use virtual and computer technology exceedingly well.
Yeah.
So virtual mechanical engineers, if you will, or virtual manufacturing engineers.
Oh,
so I think seeing universities kind of step up and start implementing this into their curriculums, I think could help quite a bit.
I think you're right, and I think it would go a long way to attract students too into the engineering disciplines, because we're still very short-handed here with the number of engineers we have compared to worldwide other countries.
Yeah, so. And that probably even applies to we'll say undergraduate or trades. The skills, I think they could also benefit from having familiarization with this technology.
Yeah.
It doesn't require necessarily a college or a university degree to be able to validate that something can be assembled, right? Any very mechanically oriented person can take a bucket of parts and say, try them together and give you a sense, if they have the physical parts, they can give you a sense of whether that's assemblable, right?
Right.
The same goes for virtual technology. When you remove that barrier of usability, it's very natural to experience these assembly processes. When you've done that, it doesn't require a computer scientist to do your virtual build studies anymore. You can give it to the workshop guy, and he can absolutely, or gal for that matter, they can absolutely use their hands to validate these processes. So I think there could be an application for that too in the trade.
Excellent.
The vocational schools.
I think that's something we just, those of us in industry and working for organizations that support manufacturing really need to take a strong look at that and really work to support those initiatives. Well, we're right up against our time limit here, Ryan. I really do appreciate everything that you have done for our industry and continue to do. This has been Dean Phillips for Longevity Industries' presentation of the Destiny of Manufacturing podcast. And we've had our guest today has been Ryan Bruce from ESI. Thank you so much, sir. We really appreciate you taking time out of your busy schedule to be here.
Thank you very much, Dean. I appreciate it anytime.
Excellent. Have a great day, everybody.
Have a good one.